The following past paper question reads that when sulfur trioxide is manufactured from sulfur dioxide and oxygen using the contact process, which condition affects the value of the equilibrium constant Kc? Now the equilibrium that we are talking about is this one, where SO2 is reacting with oxygen O2 and it is producing SO3, so they are in equilibrium. And I've balanced the equation as well. So this is the equilibrium. Now remember that the equilibrium constant Kc is the ratio of the concentration of products, which in this case is SO3. So the concentration would be squared because the coefficient in the equation is 2 moles of SO3 are being produced, divided by the concentration of the reactants, which in our case are SO2, and that would be raised to the power 2 as well, and oxygen raised to the power 1. So it's the ratio of the products and the ratio of the products to reactants. And now the ratio is always a constant. Changing concentration or changing pressure would not affect the value of Kc. There's only one thing that affects the value of Kc, and that is if you adjust the temperature. A temperature change is going to affect the value of Kc. If you increase pressure, the equilibrium is going to shift in a way to adjust, and the ratio of the concentration of products and the ratio of the concentration of reactants would always become constant. Using a catalyst would have no effect on the equilibrium position. The rate of forward and the rate of backward reaction would increase, but the equilibrium position would remain where it is, and the ratio would remain a constant. Removing SO3, if you try to remove SO3, more SO3 would be produced, and the ratio of the products and the ratio of the reactants would become a constant. So Kc is always a constant, except when you adjust temperature. Temperature is the only thing that affects the value of Kc.